A man walks along a straight path at a speed of 4 feet per second. A searchlight is located on the ground 20 feet from the path and is kept focused on the man. At what rate is the searchlight rotating when the man is 15 feet from the point on the path closest to the searchlight? Okay, so what we want to do is we want to be able to find out first what is the value of theta here. Okay, so here's theta, here's 20 feet from here, and then this is the value of x. So what do we know about the value of x? Well, it's saying here that the man is 15 feet from the point on the path that's closest to the searchlight. So that means that we know that x is going to equal 15. So the first thing we want to do is we can find this value. So if this is y, which is 20, we know x is 15, we can determine what theta is. And we can use the trig function tangent. So we can find the tangent of theta, which is going to equal the value of x over y. So we have the tangent of theta, which is going to equal 15 over 20. So now, in order to solve for theta, we're going to take then the tangent inverse of 15 over 20. Well, if we reduce 15 over 20, then we know that that's going to be 3/4. And so the tangent inverse of 3/4 is going to give us the following: 0.6435. So now that we figured out what theta is, now we're able to then move along and then determine what is the rate that the searchlight is rotating. So we're going to use, again, tangent of theta, and that's going to equal x over 20. Now, solving for x, we're going to multiply both sides by 20. So we're going to get 20 times the tangent of theta, and then that's going to equal x. So now we're going to take the derivative with respect to t on both sides. So on the left side, we have theta. On the right side, we have x. So if we want to take the derivative of 20 tangent theta, well, that's going to give us 20 times the secant squared theta times d theta over dt. And then that's going to equal the derivative of x, which is 1, and that's going to equal dx over dt. Okay, so what do we know? Well, if we look at the given information, the man walks along a straight path at speed of 4 feet per second. So we know that dx over dt is equal to 4. Okay, and what else do we know? We know that we can find the secant squared theta. Well, how do we do that? Well, let's take a look at that. So we have a right triangle. Okay, and with that right triangle, we know that we have the value of 20 here. And we have the value of 15. And so if we wanted to find the hypotenuse of that, this is going to be a squared plus b squared, which is equal to c squared. So if we have 20 squared plus 15 squared, and that's equal to c squared. And so we know that 20 squared is 400. We know that 15 squared is 225. And then that's equal to c squared. When we add this together, we get 625. If we take the square root of both sides, we know that c is going to equal 25. So if we want to find theta, okay, remember that the secant of theta is equal to what? It's equal to the hypotenuse over the value of x. So that means the value of c over the value of x, which is 20. So we want to find the secant theta, of 25 over 20. And if we reduce that, that becomes 5/4. So we know that the secant of theta is 5/4, and we know that dx over dt is equal to 4. So now we can substitute this back into our equation. So this is 20 times the secant of theta, and that's what's being squared, times d theta over dt, which is equal to dx over dt. So now that we know that secant of theta is equal to 5/4, so that means we have 20 times 5/4 squared times d theta over dt, and that's going to equal dx over dt, which we know is 4. So now we're going to square 5/4, so we're going to get 20 times 25 over 16 d theta over dt, which is equal to 4. And so we can simplify this. This goes in 4 times, this goes in 5 times. So we get 125 over 4 times d theta over dt, which is equal to 4. And now let's go ahead and multiply both sides by 4. We get 125 d theta over dt, which is equal to 16. And so therefore, d theta over dt is going to equal 16 over 125. And 16 divided by 125 is equal to 0.128, and that would be radians per second. And so therefore, we can say that the rate at which the searchlight is rotating when the man is 15 feet from the point on the path closest to the searchlight is 0.128 radians per second.